Hello friends, in our last video we learned how to create and how to use function module. We created a function module for forward function. Now in this video we will create 4 more function modules. Function module for reverse function, for hard right turn, for hard left turn and for stop. We'll also create a function module for setting up the pin mode. So let's begin. Okay, so I can write the next function module down here, but what I'm going to do is I'm going to create one tab. We learned how to create a tab for function module. New tab. I'm going to name it as function module. So it will create a tab and I'm going to use this, keep all the function modules at one place there. So this is my forward function module, and then I'm going to write the next function module for reverse. We know what we need for function module is first the type. Is our reverse function module going to return any value? No. So it is going to be void. The name, let's give it reverse. Does it need any arguments or parameters? Yes. So I can use int ls, comma, int rs. And then there will be action. For that we'll have curly brackets. Now if you see here, I've given the same names. So this is int ls here, int ls here also. So will there be a confusion? No. These variables, because I have declared them here, they are specific to this. So when we call the function module reverse, only that time these variables are created. Once the action is completed, the variables are no more present there. So if I call first forward function, the ls will use the value for forward. But after the forward function is finished, immediately they are free. And I create the same variable even for reverse. So that is not a problem. Now here I need to write the action. Copy and paste this. And for reverse, the left motor should be clockwise. Clockwise means first pin high and second pin low. We need to remember these pins in this order so that we know first high, second low is clockwise for that motor. For reverse, the right motor should go anti-clockwise. Anti-clockwise means first low and second high. And that means we have created our function module reverse. Now let's create function module for hard turns. So I'll copy this. Now I'll paste it here. Hard turn, is it going to return any value? No, so it is going to be void, no change there. I'll change the name. I'll call it hard left turn. Hard left turn. So I'm using the naming standards used by Arduino, where I have 3 words hard, left and turn. Second and third word, first letter I have used as uppercase. Okay, for hard turns, do we need 2 arguments? No, because hard turn we should always have the same speeds. And hence I will only have one argument. I'll call it, let's say, SPD, speed. And I'm going to use the same speed for both the motors. Okay, now let's understand for hard left turn, left motor has to go reverse and right has to go forward. Left reverse means left has to go clockwise. And that means first high, second low. So that is correct. And the right motor has to go forward. Forward means clockwise. For clockwise, first high, second low. Here first is low, so we'll change it to high. And second low. Correct. So that is our hard left turn function module done. Now to do hard right turn, we'll copy this and we'll make hard right turn. Now hard right turn, right motor has to go reverse. So right motor has to go anti-clockwise. Anti-clockwise means first low. So in right motor, first low, second high. Left motor has to go forward. For left motor, forward is anti-clockwise. Anti-clockwise means first low. So low and high. We are taking only one speed which already we have given here. So that's hard right turn done. Now let's do it for stop. Again, no value to be returned, so void, and let me call it way stop, because stop is a keyword in Arduino and I don't want to use that. And using the naming standards of Arduino, S is in uppercase. Now, do we need any speed to be provided to us for writing the actions for stop? No, we know that for stop the speed is obviously 0. So why should we expect the speed to be given by the user? We don't want any speed. So we don't want any arguments. Now here is example where we don't have any arguments. Here is example where we have one argument, and in forward and reverse we had 2 arguments. Now for stop we know both the pins have to be in the same polarity. For both motors, both the direction pins have to have same polarity. And speed is going to be 0. Okay, so that means this is our function module for stopping the vehicle. We'll also create the function module for setting up the pins for the vehicle, and we'll call it, let's say, vehicle setup. Okay, any information we need from the user? We don't need any information because we know all the pins, we know what is the mode, and that is not going to change. Pins are fixed for left motor and right motor, and we know that the mode has to be output, so we don't need any input from user. And action is going to be pin mode for each pin. So this is going to be same for all the 6 pins. And what is the type of the function module? It's not returning any value, so it is void. So that means we have created 6 function modules which we use very often in the vehicle programming. And now in our programs, we can use these functions instead of writing that entire code. Now let's save this function module and save this as a template. The reason is whenever we create a new program, these function modules are not going to be there. Then do we write again and again? No. So what I do is I create a template program, and every time I create a copy of the template program and only change the main program based on our requirement, so that function modules are always available. So let me save this as template. In our next video, we will make use of these function modules to write various programs.